So question 18 is I don't know, it's more of like a comparison question. I don't really know what to say. It's more like kind of algebra science, kind of geometry, I guess. I guess you can say it's a geometry question. So we have like these two quadrilaterals, and we're basically just asking, let's compare the areas and the perimeters of these two quadrilaterals. So the idea is like, let's look at quadrilateral one, right? If I were to draw this red line, I can split that quadrilateral into like this red triangle plus this red triangle. So it's like two red triangles. Or we can do like something very similar to the previous question, right? Like we can kind of imagine taking this blue triangle and like translating it upward, right? I guess this is like a technique to learn, I guess, right? Like maybe we don't know how to find the area of something, we can like translate pieces around to get something that we know how to do, right? Because if we were to translate this bottom red triangle here, I get this blue triangle up here, this blue triangle up here. So the sum of the two red triangles is just the area of this square here. And we know that the area of that square is just 1. So the area of quadrilateral 1 is 1. So area of quadrilateral 1 is equal to 1. And then like to find the area of quadrilateral 2, we can kind of like what we can do is like we can again split it in half. So the area of this red triangle is 1/2 base times height as area 1/2, and the area of this blue triangle here, notice that its base, this length here, is also 1, and this height is also 1. So the area of that blue triangle is 1/2. So 1/2 plus 1/2, we find that the area of 2 is also 1. So the area of quadrilateral 2 is also 1. So we find that the area of quadrilaterals 1 and 2 have this, they're equal. Like quadrilaterals 1 and 2 have the same area. So we can immediately eliminate choice A and eliminate choice B, right? Because choices A and B assume that the two quadrilaterals have different areas, which is clearly false. And now we have to compare the perimeters, right? So now we have to compare the perimeters of the two quadrilaterals. So to compare the perimeters, notice that like if you look at the first one, this has length 1. Like this red segment has length 1. This red segment has length 1. And these two like blue segments, right? These two blue segments, they each have length √2. Just by the Pythagorean theorem. So the perimeter of quadrilateral 1 is going to be 2 plus 2 square root 2. And for quadrilateral 2, notice that like we have like this length here. So we have this length, this has length 1. These two blue lengths both have length square root 2. And this like green length, this long green length, we can form a right triangle, right? With lengths 1 and 2. So by Pythagorean theorem, square root of 1 squared plus 2 squared, that equals square root of 5. So that tells us that like this green length has length square root 5 by the Pythagorean theorem. So the perimeter of quadrilateral 2 is going to be 1 plus 2 root 2 plus root 5. So now we have to compare like these two perimeters. So this is the perimeter of quadrilateral 1, and this is the perimeter of quadrilateral 2. So notice that like they both share this 2 square root 2, right? They both have this 2 square root 2 in them, so we can kind of just ignore them. And now we just have to compare which one's bigger, 2 or 1 plus the square root of 5. So the idea is like square root of 5 by itself is already bigger than 2, right? Square root of 5 is like going to be like 2.2 something, something, something. So 1 plus that is going to be like 3.2 something, something, something. So that tells us that 1 plus square root 5 is bigger than 2. So that tells us that the perimeter of quadrilateral 2 is bigger than the perimeter of quadrilateral 1. And that would tell us that the perimeter of quadrilateral 1 is basically less than the perimeter of quadrilateral 2. And that would give us like choice E. And we'd be done. I think like the main idea for this, there was nothing really too tricky about this problem. We just kind of found the areas of the two quadrilaterals. We found the perimeters of the two quadrilaterals and we just compare them. So this is a pretty direct problem. There's nothing like, like it's not many like smart or like tricky things you got to do. You can just like do it directly, I guess.